what we want to integrate here is 5x to the 7th minus 2x plus 3 dx. So we can think of this problem as two different things. We can separate this into three separate integrals using just the sum and difference properties. That we can just do this as three separate integrals, just like how if we were taking derivatives, and this will just take the derivative of this whole entire statement, we would take the derivative of each individual term and then tack it all at the end. Same thing applies for integration. So we just want to individually integrate each term. So I'd have the integral of 5x to the 7th dx minus the integral of 2x, and we could have put the 2 on the outside of the integral, same thing with the 5 over here, but I'll just leave the constants on the inside, plus the integral, take on the dx here, dx, plus the integral of 3 dx. Now typically after you get a level of comfort with integration, you probably wouldn't rewrite this and spend 10, 15 seconds or 20 seconds rewriting the entire problem just to separate into three integrals. But just for the sake of explanation here, I'm separating into three separate integrals because that's just like the process that's behind it. So from here, we can individually integrate each term. So this one, we're going to use power rule, 5x to the 7th. So this is going to be 7 plus 1 divided by 7 plus 1. So that's going to give us 5x to the 8th. 7 plus 1 is 8 over, and then that's just going to be that exponent, because if we take the derivative, 8 times 5 divided by 8, the 8's cancel out, and just leaving us with that 5. And I'm not going to put plus c on each individual term. We'll just tack on a plus c at the end. But what also makes this kind of nice, separating this out into three separate integrals, is because now I really don't have to worry about this minus. Because some people struggle with, like, well, what if this was the integral of minus 2x dx? Like, what do I do with that negative? Like, don't let the negative freak you out. You could just rewrite this as negative integral of 2x dx. And then you're like, oh, it's just the integral of 2x. And you could even bring out that 2 and then just deal with the integral of x. So there's really easy ways to just get around things that look scary. So I'm going to have minus, and then this is going to be 2x to the first. So 1 plus 1 over 1 plus 1. And I'm not going to simplify anything until the end, because I just want to write everything out. So minus 2x to the second, 1 plus 1 is 2. And I know I'm seeing this, I know. Plus integral of 3. 3 is a constant. So that's just going to be 3x, because when we're integrating a constant, let me do this off to the side. Let's think about that logically. If I just have a constant, what I technically have for my x is x to the 0. Because anything to the 0 power is 1. So 3 times 1. So x to the 0. So if I'm adding 1 here, 0 plus 1, this becomes 3x to the first over 1. So we just get 3x. And then we tack on that plus c. But I know I still have to simplify those 2's there. So let's go ahead and do that. 5x to the 8th over 8 minus, bam, x squared plus 3x plus c, and that is the integral of 5x to the 7th minus 2x plus 3. This was the extremely long, drawn-out process. Once you get really comfortable with integrals, you don't need to do this step. You could probably even get from here to here all in one quick swoop, because you could just simplify without, you can see this, this is going to be squared over 2. I'm not even going to write that 2 over 2. I'm just going to cross that out in my head and then just write x squared. And then that's just 3x. So this could have been like 45-second video if we wanted it to. So hopefully this helps.